Hey guys, David here and welcome to another video. I want to give a huge thank you to PCBWay for sponsoring this video. They make super high quality PCBs, but not just that, they also have manufacturing services such as CNC machining, 3D printing, laser cutting, all of that good stuff. And what this could be really useful for is if you're building a CNC, but you don't already have a CNC to build a CNC, well, you can just order all of the parts machined from PCBWay and it's going to be quite reasonably priced compared to finding a local shop that bothers with a one-off job like this. So make sure to go check them out down below. Welcome to a new series on this channel, series where I'm going to be building a brand new CNC. I have designed this one from basically the ground up and I've already started building it. Well, you have seen some of the machining, and in this video I want to show you what I've done so far. I want to kind of go over the design later in the video and show you all the different decisions that I've made, what kind of parts I'm going with. And then more specifically in this video, I'm just going to be focusing on all the different plates that I'm machining on my current CNC, the Rhetoric Killer Bee. So the purpose for this new machine is going to be, well, just making more guitars and better guitars. The Killer Bee is great and I've built many guitars with it. It just is an awkward size where it is just barely not long enough that I can make neck through guitars directly on it. So just an extra 5 or 10 centimeters of width of travel in the length direction, which is X for me right now. That would solve just many problems. And well, while I'm building a new CNC, I might as well upgrade to kind of a bigger tier. So this one is quite the upgrade, and while I was designing it, I kind of kept getting more and more heavy builds. So this here is 25mm thick aluminum plate, and this will be one of the gantry plates, like one of the side plates holding out the gantry. So that's the kind of machine that we're talking about. And I've also managed to secure a couple of sponsors for this build. So I'm really proud to announce that I'll be working with lead shine for all the motion. So there will be all servo motors from lead shine for all of the axes, which is going to be just great at having the reliability and speed of servo motors. Then for the spindle, I'm working together with Spinergy, and this will allow me to finally get my dream of an ATC spindle. And this means I can just have a rack of tools in the back and I can automatically change between them. And that is easily half of the time it takes me to make a part on the CNC. Is just me sitting there, changing out tools, touching off the tools, and by having them all pre-set up in nice tool holders, being able to automatically change between them. For one, I could just start a program, do something else for an hour instead of having to come back every 15 minutes. And also the program's going to run faster because the tool changes a lot faster than me manually changing it. But, well, I don't think I have to convince you about how great automatic tool changes are if you have ever seen any machining footage on YouTube. Then finally, the frame itself, it's based on the Rodrick Stronghold Pro, which is kind of the upgraded version of the Killer Bee. Well, the new version of the Killer Bee that they have now is the Stronghold, and then they have a Stronghold Pro, which is even beefier. And I would have actually just went out and bought a Stronghold Pro, except the smallest size is just too large from a workshop. And then I started looking at just modifying it, cutting it smaller. And then I saw a couple of other things that I wanted to change about it to upgrade it a bit more. And well, it snowballed from there. And eventually I was just like, it's going to be easier building one from scratch. So the design is heavily leaning on the Stronghold Pro, but with quite a bit of improvements on, well, at least I think they're improvements. So let's hop over to the computer and I'll show you the rest of this design.
So here you can see the current state of the 3D model. It is mostly done, but not quite. There are a couple details that I still need to figure out, but for the purposes of this video giving you an overview, it's perfectly ready. Now you can see that you cannot see a lot of the mechanics, and that is by design. One of the big gripes with the Killer Bee and also with the Stronghold and Stronghold Pros is that there's just no thought given to any sort of protection against the chips. They're just kind of very open. All the dowel screws and linear motion components are just out in the open. Limit switches with like bare contacts are installed where metal chips can short them out. That just for me does not work. And I've already done a bunch of work to my Killer Bee to kind of somewhat mitigate some of the chip problems, but in this one I do want to build that right in. And well, these chip guards here on the y-axis are quite similar to what I've done for my Killer Bee. They're just simple sheet metal covers, but here on the x-axis I will actually be getting custom bellows made that cover it perfectly and mean that the ball screw and the linear rails and all of those components here are protected from the chips. But for right now, I'm going to just quickly hide all of those, that way we can actually see what the machine does underneath. So just to give you guys a bit of reference of the size of things, we have about 720 millimeters here on the x-axis for the table, and then the table, the like spoil board, is just a bit over a meter in length. But then we also have this section here where it's overlapping, and that is like the machine can still reach here in the front. And that is designed so that I can clamp a guitar body here vertically and do some machining work on the side. This is not a feature I was able to just very simply add since I'm building my own, but adding that to an existing machine that has, I don't know, cross braces here in the front will be a lot more difficult. Then you can also see that I have mainly just a big spoil board here. I'm not exactly sure yet how I'm going to organize that, but probably just have a grid of locating holes and some threaded inserts in there. And then in the back corner, I actually have an aluminum fixture plate from Sonda's Machine Works with some mod vices, and that is just going to allow me to much more easily do like metalworking parts, making custom string retention things and all of that stuff, or even small wooden parts where I really would like to use a vise. And these ones are really nice because they're very low profile and can be arranged in any way on this fixture plate, and just super versatile setup, and should allow me to do some good work. I've already have this, I've used it once or twice, just putting it down on the bed of my Killer Bee, but here it will be permanently bolted in place. And all of these jaws are removable, so if I want to put down a big sheet of plywood or something, that is removable and I can use the full work area. Then here in the back you can see the rack of tools. I'm planning on having probably 10. I'll have to see exactly how close I can space them, but 10 should most definitely fit. I also have already started modeling here the dust guard, the dust boot, and taking inspiration from Marius Hornberger. It will be a completely over-engineered dust boot, but my issue is that I will not have an enclosure for this CNC, whereas my current one does. And well, traditional dust boots kind of suck, because if you have a lot of up and down movement in your tool path, the dust boot will either get smushed into the table or it will be not really covering. So this will be independently controllable in height. That way I can just set it to whatever height is appropriate for the workpiece, and then the spindle moves independently of it, and the dust boot will always stay at the perfect height. Right now that is not modeling yet, but I'll probably have some very small linear rails here next to it, and that's why there is a bit of extra space. Then behind it is one of the stars of the show, the Spinergy X22. It's going to be 2.2 kilowatt 4-pole spindle instead of the standard 2-pole. That should give me just some more torque at the low end. And it's the air-cooled version because it's just easier to implement, and for the price for the air-cooled and water-cooled is the same, but you need to add the chiller to the water-cooled one, so that adds almost another grand to it. So I went with the air-cooled. And also the fully tool-changeable one, of course, to be able to make use of the SK20 tool holders. Then for the axes, I'm using this 40 series aluminum extrusion, getting that from Rodchick. It's the same that they're using on the Stronghold Pro, and I really like that choice. It's a lot sturdier than the like 20 or 30 series that is used often in CNC machines, and just makes it so much easier to assemble everything than having anything custom made. That was my other kind of design goal, apart from just meeting my end goal criteria. I was trying to make this as easy as possible to build with as few custom components. Now, of course, I still have all the plates, but these are all relatively easy to machine and can easily be done on the Killer Bee. Then I have these quite beefy linear rails. These are 25 series linear rails and 60mm ball screws. Once again, just straight up copy from the Stronghold Pro. As well, I don't have the engineering knowledge to kind of really compute my requirements, and this works well with the size of aluminum extrusion. If you go smaller, it doesn't really fit on it that well anymore, so that's as good a reason as any for me. Then what I am doing differently is I'm flipping around all the motors. I want to keep this footprint as small as possible. This machine will be bigger than my Killer Bee, but by not having an enclosure and by everything being kind of designed in a compact way, although the travels are actually quite a lot more, the overall footprint will only be marginally larger than the Killer Bee, which is good because I already don't have any space in my workshop. So I will be using some pulleys here with belts, and then the motors, those belts can be tensioned with these motor brackets that you've already seen. It probably does add some elasticity and is not as ideal as directly driving the ball screws, but it should probably be fine. And I've been using this sort of design on my Killer Bee for the X-axis already, and I haven't really had any issues there. The design for the gantry itself is once again made out of this 40 series extrusion, but while they do make kind of C profiles for some extrusions, I needed something larger, so I'm kind of making my own C profile. So I have just a 40 by 80, a 120 by 80, and then another 40 by 80, and these are just kind of arranged in this profile, and this should give me quite a large distance between here for some proper strength and make sure that this doesn't bend around. That's quite a bit of an issue with the Killer Bee, and I can imagine that the Stronghold Pro and the larger sizes also will suffer from that, that if there's a lot of force upwards on the spindle, it does tend to kind of want to have a bending motion. That's quite normal for these gantry style machines, but I'm going to try to overbuild this as much as possible. I've also spaced the carriages for the linear rails apart as far as possible, quite a bit more than are done on a Stronghold Pro, and that should just also help with rigidity. In terms of seat travel, I actually have quite a decent amount. I wanted to have enough table clearance that I can have a vise on here. I can have maybe a vacuum, I can have like a vacuum chuck on top of my regular spoil board, and then put a 40-50mm guitar body on that, and still have enough clearance here to be able to use longer tools. I haven't had much issues in this regard with the Killer Bee, but being a more sturdy machine, just adding a couple of centimeters in C should be fine. Though with one of these style machines, it's always a big trade-off how much C reach you have versus how rigid it is. I think that just about covers it for a general overview. If you have any questions or suggestions, might be a bit late for suggestions, but you can still leave them down in the comments. I'll gladly read them, and always open to learn some more.
Now that you have an idea of what I'm building, let's talk a bit about machining these aluminum plates. Now, even the kind of small ones, which are just end brackets that are holding the 40 series extrusion together with the end bearing. So this is more or less almost a cosmetic part, just holding a bearing in place slightly. This is all 15mm thick aluminum. The motor plates are actually thinner. They are 8mm, and they mount on these plates like this, and can slide back and forth to tension the belt. And these ones, well, of course, mount to motors. So these ones are 8mm. The most of the other smaller plates are 15. Then I have some 20mm plates for the Z-axis assembly, and then the big chunk is 25mm plates for the two gantry plates. And well, this will definitely be a challenge for the Killer Bee. The Killer Bee is not designed to machine 25mm aluminum sheets. It's designed for wood and some small aluminum parts. 8mm stuff, perfectly fine. But 25, well, let's see how that goes. I kind of worked my way up, starting with the smallest ones with these motor plates, and definitely there was a learning curve. I've cut some aluminum in this machine before, but not that much, and I really needed a recipe that kind of goes quick and removes a lot of material. Otherwise, these plates are going to take 5 hours, and I have no interest in standing here for 5 hours. So the first one actually cut out well, but the surface finish was atrocious. So I moved up to a larger tool. I was using a 4mm single flute at first. Then I moved up to 6mm single flute, which left a much better surface finish, just a more rigid tool. And I also had a slightly more stubby version of it. Now, apart from that, kind of just using the wrong tool, I've had two major issues that are somewhat connected so far with cutting these parts. And first issue is chip evacuation. Just kind of getting the chips out of the cut. Now, on a big VMC, you have flood coolant that is just going to wash them out. And while coolant says it's going to cool, that is also one of the things it does. The almost more important part is just getting the chips out of the way that it cuts. Whenever you start to not evacuate the chips properly, you start recutting them. That creates a lot of friction, which creates heat, and then the chips start sticking to your tool, which then leads to really bad surface finish, and not much later your tool's going to break. I definitely had that happen once or twice. And then connected to that, to kind of like this issue of chip evacuation, is just heat buildup. If you're slotting quite deep and you're not always perfectly clearing the chips, even if most of the time you are, and you're kind of rubbing in the sidewalls because you have to go in shallow passes, these plates get really hot while machining, and when they're really hot, then the surface finish gets a lot worse because the chips stick to it much more easily. It doesn't take as much to kind of sort of melt the chips, or like not fully melt, but get them soft enough that they stick. So that's been my other issue. One fix that I basically did right in the beginning was adding air blast. That's just the easiest way of helping with chip evacuation, getting some coolant in there. Ideally, you would have like minimal quantity coolant also added to that, but kind of the way this machine is set up, I don't want to spray a bunch of coolant in there. I have on some of the worst parts where I saw I was getting kind of bad I have just manually added some drops of oil into the airstream, and that kind of acted basically like a minimal quantity coolant, and you could immediately see that it would cut nicer and the chips evacuated better. But apart from that, it's just a basic air blast. The only other thing that I was able to do is just continue to revise my cutting strategies. I just started out very basically just doing 1mm step downs and just 2D contour to cut out all of these shapes, just slotting, and that works great in the beginning, but once you get deeper, especially in like the 50mm plates, there's just a lot of the tool kind of rubbing against the walls, and it's cutting on both sides, which is never a good plan. So what ended up working really well, and what I will be using on this big 25mm plate, is a technique that I actually use on cutting on wood as well, where I kind of do step downs and finishing passes, but they're not really finishing passes, but more just creating a wider channel. So the first time that it goes around is like 2 or 3 millimeters away from the contour, and then it does a step over of this 2 or 3 millimeters, and then does that. It's basically like a roughing pass and a finishing pass, but on every level. Otherwise, I'm just going down, and then the very last level, I'm doing a finishing pass to clean it up. But here I'm doing a large step over and then a finishing pass on every level. And that just means that while it is slotting, it is only ever really rubbing on one side of the tool. And the finishing cut that is actually cutting the part is not a slotting operation anymore, but only cutting on one side. And that leaves a much better surface finish already. And it means that the chips can clear more easily because there is a wider slot and there is less heat buildup. And that just worked a treat, and there were much fewer issues. And the other issue is small holes. You can already see that I didn't drill things. I don't really trust this machine for drilling, especially not in aluminum. So the stuff that I can bore out works great, except like 5 millimeters and below, it starts to get kind of problematic, as a 4mm tool can cut a 5mm bore, but chip evacuation going 15 millimeters deep is kind of a nightmare, and these cuts did not sound nice, and I definitely did break some end mills, even going as large as like 8mm bores. I had issues. The larger ones, the like 12mm ones, I was able to cut with a 6mm end mill, and they worked great, but the smaller ones, I definitely had issues. So usually I would go in, cut the smaller bores, and then use those as additional hold downs. Otherwise, I'm just using masking tape and super glue. So masking tape on both sides, the bed, the part, burnish it down really good, and then add some super glue to hold these together. And that actually holds really well. And the screws are just basically there as an insurance policy and like a force multiplier. Well, I believe that's just about enough for story time. I will be drilling and tapping the smaller holes, so like the 3mm and 4mm holes. I will be just on the drill press drilling those and tapping those threads. But let's put this giant piece of metal on the CNC and see if we can cut it. Alright, so here we go. All of the plates are machined and they look overall quite beautiful. Now, of course, not all of the finishes are as perfect as I would like them. I am still a beginner machinist in aluminum on the Killer Bee, but you can definitely see which ones I did first and which ones I did later, and there is significant improvement, which is always good to see. Now, all of this machining has created a lot of chips. Now, it is quite impressive that the Killer Bee, which is a hobby router, has created, which is, I don't know, 5 kilograms of aluminum chips in just a couple of hours of machining. It's like not even that bad. Like the big plates, they took roughly an hour, and the smaller ones, most of them like 15 minutes. So maybe 4 hours of machining in total. Not that bad at all. Now, not everything quite went smoothly. I had a couple of issues on this big plate here, but funny enough, they were not the fact that it's a 25 millimeter thick aluminum plate. But the Killer Bee has limit switches which have some exposed contacts. Well, at least behind them, like PCB, but it's open. So these nice long metal shavings that I was creating while finishing, so they're maybe like 15 millimeters long, they were kind of flying all over the enclosure because they're quite light, it's finishing past, and not once but twice in a row did they find themselves behind the PCB for the y-axis, for the x-axis limit switch, and shorted it out, which means that the machine registered a limit switch trigger, which causes an error, of course, because it thinks it did a big oopsie and it ran into itself. And so the machine stopped. I had to, well, clean out the chips and then try to re-find proper zeros and whatnot. It was fine. It's just kind of funny that the only thing that went wrong was the machine misbehaving. But then I just basically hot glued the crap out of that limit switch, and then all of the other plates went perfectly fine. And there was basically no hiccups on the second 25 millimeter plate, which had even more machining to do. Now we did kind of settle into a rhythm where for like the deep slotting passes where it's actually doing a bunch of slotting, I would put in a couple of drops of oil every 2 or 3 passes, just to keep everything lubricated, and that keeps the tool a lot happier. There's no gumming up, the surface finish is a lot better, but you do get quite a bit of smoke. But I think this is completely harmless, and there was no smell, and it cleared out perfectly fine. But you could definitely see when the hot tool was coming through and creating the smoke. I also started on drilling all the holes and tapping all the threads, but I haven't quite finished. There is a lot of holes and even more threads that I need to drill, so that's quite a fun adventure. I could have went ahead and come up with a thread milling operation to do all the threading, and I was gonna do that at least for like the M5 or something like that. But in the end, I just didn't bother. Like switching between tools with the manual tool change is such a chore that in the end, I'm pretty sure I'm faster doing it by hand than having to do 5 tool changes on a part that otherwise takes 15 minutes with 1 tool change in the middle. Having like 4 tool changes is going to make it not take 20 minutes, but instead half an hour or even more. And so I can just as well do it by hand. Now, of course, once this machine is done and I have 10 tools available, then this is a different story. But now I think I have been rambling a lot in this video already, and it's getting quite long, so I think we gotta call it a day here. I'll finish the rest of the holes off camera, and then in the next video we're gonna start assembling this beast. I'll probably first do some like dry assembly of the components, and then, because I actually have to remove this machine first before I can build the new one fully, because I don't have another table big enough, and I don't really have a place to keep this like operational that is not this table. So if you're in the market for a desktop CNC, my Ratrick Killer Bee, which you just saw machine all of these aluminum plates, those machines would great, is available for sale. You have to come pick it up in central Switzerland, so I guess this only applies to a very small percentage of my audience. But if you are, and you're watching this video when it comes out, I'll have the details for that linked down below, and you can get in touch with me. Other than that, I do want to give a big shout out to all of the sponsors for this project. Since I recorded the last clip, Masso has now also come aboard. So to repeat, we have Masso sponsoring the controller. We'll be getting the same controller as I have on my Killer Bee, but now using the new software, and I'll give it another try, use the automatic tool changing functionality of it, so that should be great fun. We also have Leadshine providing all of the servo motors for this build. Then we have Spinergy, which gave me a huge discount on this beautiful X22 automatic tool changing spindle and all of the tooling to go along with it. Just to give you a reference, just the tool holders alone at full price cost about the same as this entire Killer Bee. So I'm definitely grateful for that discount. And of course also a huge thank you to this video's sponsor, PCBWay. You can check them out down below as well. And with that said, make sure you guys are subscribed, because there will be a lot more videos about this project, and they should hopefully actually come out fairly regularly. Now, not every week kind of thing, but I'm hoping to have like every 2 to 4 weeks a new video in this series coming out. And I also hope that they will not all be this long. This just kind of got out of hand. You can also leave any comments down below, suggestions, what do you want to hear about, what kind of questions you have. I'm fairly up to date here with these videos, so I will be seeing them for the next part. So with that said, thank you guys for watching, and I'll see you next time.